nuclear reactions. In the previous class, we studied about the structure of nucleus. In this session, we are mainly discussing with the type of nuclear reactions. Before that, we have to know a notation, a symbol for expressing the nuclear reaction, which is known as Bethesda notation. So what is a nuclear reaction? A nuclear reaction is a transformation of a target atomic nucleus, which is usually at rest, by bombarding it with projectiles of light nuclei, free nucleons, or photons of adequate energy. A nuclear reaction is generally represented by an equation X A1Z1 plus A2Z2 gives B Z3A3 plus Y A4Z4. Here this X representing the target nucleus, A1 is its mass number, Z1 is its atomic number. A is the projectile which hits on the target nucleus, and A2 is its atomic number and mass number, Z2 is its atomic number. And small letter B is the ejectile or the particle. In addition to a product nucleus, some particles are also emitted, which is known as ejectile, and it is represented by B, and Y is the product nucleus. It can be a shorter form of writing this type of nuclear reaction is introduced by Bethe, and so by it is known as Bethe's notation, and can be represented by X, A, B, Y. A2, A1 X, AB, A2 Y. A1X representing the target nucleus, and B is the projectile and ejectile, which is written in the bracket, and also the Y is the product nucleus. Here is a Bethe's notation for some of the nuclear reaction, the transformation of magnesium into sodium, and here the projectile is a deuteron D, and the ejectile is an alpha particle. Similarly, the transformation of chlorine to sulfur, copper to sodium, and sodium to sodium, and sodium to the isotopes. The isotopes are sodium. So it is a N-gamma reaction, and N-gamma reaction means here neutron is the projectile and gamma photons are emitted as the ejectile particles. So the simplest form of writing this nuclear reaction is known as the Bethe's notations. And then we are going to the type of nuclear reaction that we have already mentioned in the previous session, and here there is more than fission and fusion. There is another type of nuclear reaction is discussed in this section. That is, first one is the elastic scattering. Here A equal to B, X equal to Y. This means that the both projectile and ejectiles are same, and product nucleus also and target nucleus remains same. So what is the mechanism here? Here when the incoming particle means projectile, strikes on target nucleus, the projectile loses a fraction of its energy, that is kinetic energy, in translating the latter, means that in translating the target nucleus into product nucleus. Here there is no change in total potential energy and kinetic energy, so we can say the energy is conserved. That is why it is known as elastic scattering. The amount of energy transferred to the target nucleus by the projectile is given by the equation relation EM. Here M is the capital M, equal to 4 mm sin square theta by 2 divided by M plus M square EM. Here EM, small letter M, is the initial kinetic energy of the incident particle of mass M, means the mass of the energy of projectile of mass M, and E capital M is the kinetic energy gained by the target nucleus of mass M. And theta is the angle between initial and final path of the particle. Initial path, final path, there should be some angle difference. There should be some path difference. That is why there is angle theta. And Em dash is the the residual kinetic energy of the incident particles. Here, the total energy of that is the energy of the incident particle equal to the energy of the target nucleus plus E dash m, that is the residual kinetic energy of the incident particle. This means that, the total energy, that is energy of the incident particles, is equal to the sum of the energy of the target nucleus plus what fraction of energy, that is that fraction of energy is transferred by projectile into target nucleus. The sum of residual kinetic energy and kinetic energy of target nucleus equal to the energy of the incoming particle. So we can say the energy is, there is no change in energy. So the law of conservation of energy is observed. And this is what happens in elastic scattering. The next is the inelastic scattering, second type. Here the process of scattering is considered inelastic if some of the kinetic energy of the particle is used up in rising the potential energy of the target nucleus in some way or other, as in exciting it to a higher level. Here the kinetic energy of the system is not conserved. That is why it is known as inelastic scattering. That is, this can be explained by an example, the transformation of a silver nucleus into its product nucleus, that is silver. When neutron bombard with the silver nucleus, target nucleus, what happens? Silver nucleus is excited to higher level because it accepts a fraction of energy from projectile and to get transferred to higher level, and in the higher level is can be represented by 107 MeV, that is in a metastable state or high energy state. In the high energy state it is very unstable, but even though it is having a long life of 44.3 seconds. After that it undergoes internal transition and can be loses a fraction of its energy and converted into product nucleus. So when during its transformation into product nucleus, another neutron is also ejected from the nucleus. That is the ejectile. Here both the projectile and ejectile are the neutrons. That is what happening in inelastic scattering. And the third type is photonuclear reaction. Like its name, photonuclear reaction, that is nuclear reaction introduced by light or photons of definite energy. Here the energy of photon is considered as greater than 1 millielectron-volt and is referred to as photonuclear reaction. Here the projectile is a gamma photon, B is more often a neutron or a proton or very high energy photons. That is the projectile may be deuteron, tritron. Projectile may be gamma photon and ejectile may be deuteron, tritron, alpha particle or mixture of particles, proton, etc. That is a variety of ejectiles are there. Here is an example, the transformation of beryllium nucleus into beryllium, and here beryllium in ion to beryllium 8. Here gamma photons are hit on the target nucleus and it is converted to product nucleus. Here the isotopes is obtained and the gamma neutrons are emitted. That is generally we can say the reaction introduced by light is known as a photonuclear reaction. And the fourth type is radiative capture. In the radiative capture, the particles on capture leads to the emission of radiation in the form of one or more gamma photons. Here the particles may be neutron. Generally neutrons are the projectile particles or incoming particle. When it is hit on the target nucleus, some gamma photons are emitted from the target nucleus in addition to the conversion into its product nucleus. That is, in addition to product nucleus, some gamma photons are emitted. Here the example, sodium to 23 sodium 24 sodium N gamma. Usually this type of reaction is also known as N gamma reactions. N gamma means the neutron is the projectile, gamma photons are the ejectiles. And in addition to N gamma reaction, there is P gamma reactions also. P gamma reaction means the reaction reduced by projectile. Proton. Here protons are the projectile. Here is some examples. Then other types of nuclear reaction. A large variety of other type of nuclear reaction is also there. PN reaction, NP reaction, N-alpha reaction, alpha-N reaction, DP reactions, DN reaction, alpha-T reactions, depending upon the projectile nature or type of the projectile used and the ejectile particles are emitted. Then in addition to this, more than this, there is some special nuclear reactions also there. And first one is evaporation. In evaporation, when the projectile hits on target nucleus, there is more than one ejectile particles are emitted from the nucleus. Here is an example, the transformation of cesium to lanthanum. 133, here the mass number remains same, but the alpha particles are the projectile. 4 neutrons are emitted from the target nucleus. In the case of aluminium to sodium, deuteron is the projectile and proton and alpha particles are emitted from the nucleus. And second one is spallation. Spallation means which is more violent than evaporation. This means that a large number of nucleons are thrown out and the product nucleus is very much lighter than the parent nucleus. Here is an example, the copper to sodium. Here projectile is a proton. When proton hits on target nucleus, that is copper nucleus, what happens? More than one nucleons are emitted. Here is a nucleons emitted is a proton, 3 neutron and 9 alpha particles. So what happens? The product nucleus, it is very much lighter than the target nucleus. Here the copper is 63 and 24. During spallation reaction, 24 sodium is produced. It is very much lighter than copper. So bromine to scandium also example for spallation reaction. And third type of special nuclear reaction is fission reaction. Fission reaction that we have already discussed. That is the process of splitting a heavier nucleus into lighter nuclei of comparable mass and energy by a neutron. And here for one neutron, 2 neutrons are ejected. And fourth one is a fragmentation reaction. Fragmentation reaction means when a nucleus is on heavy excitation, that is means around 0.5 giga electron volt, what happens? The target nucleus is splits into a light and a heavy fragment. But the n by z ratio remains ratio as in the parent. Remains same. This means that this is known as a fragmentation reaction. And during excitation, what happens? The nucleus accepts energy, it will undergo excitation, but this energy is not equally distributed between the light and heavy fragments. So the former decays by beta elimination, and here the lighter nuclei later it decay by beta elimination, and heavy fragments will undergo evaporation reaction. That is the splitting of a heavy nucleus into two fragments, in which one is heavier and other one is lighter. That is the fragmentation reaction. And fifth one is a stripping reaction. Stripping reaction means a projectile does not react as a whole with the target nucleus, but one or more constituents of projectiles alone captured by the target nucleus. In this way, products heavier than target are produced. Here in this case, 63 copper bombarded with a deuteron. Actually, what is a deuteron? Deuteron is a combination of neutrons and proton. One neutron plus one proton, that is equal to deuteron. D equal to N plus P. Here in this case, when neutrons are absorbed, it is converted into 64 copper and a proton is ejected as an ejectile particle. Okay. In this case, this reaction is the NP reaction. Means only from the even though the projectile are deuteron, the deuteron contains both one neutron and one proton. One deuteron as such is not absorbed by the target nucleus, but its only one of its constituent particles is absorbed by the target nucleus. Here it is neutron. and it is converted into 64 copper, which is more heavier than 63 copper. So we get a heavy fragment. This type of reaction is the NP reaction. Here N is the projectile and P is the ejectile. Ejectile, that is protons are ejected. Here is other example, 27 aluminium. 27 aluminium when bombarded with the projectile. Here the when it is 63 copper is 27 aluminium is bombarded with a proton, we get a 28 silicon. That is so 27 aluminium when it is bombarded with the N14 6 plus ions, nitrogen ions. Here the N14 6 plus ions contains 3 types of particles, that is N plus P plus 3 alpha. It consists 1 neutron, 1 proton and 3 alpha particle. When 27 aluminium is bombarded with a nitrogen ion, what happens? Then when proton is act as a projectile, we get 28 silicon. The particles other than proton, that is N and neutron and 3 alpha are ejected as projectile particles. When alpha particles are absorbed or when alpha particle act as projectile, we get 31 phosphorus. So neutron and proton are ejected as ejectile particles. When 2 alpha particles are absorbed by the target nucleus, we get 35 chlorine. When 3 alpha particles are absorbed, we get 39 potassium. Thus, depending upon the type of the particles are absorbed by the target nucleus, we get different types of products from the same target nucleus. And ejectiles are different in all cases. That is what happening in stripping reactions. This is it's a different types of nuclear reactions.